Hello, everyone. We are Group 6, and our members are Nisha Casey, Harry Shin, and myself, Khadijah Wigley. Today, we are going to delve into a report by Thomas Mack of the Casualty Actuarial Society titled Measuring the Variability of Chain Ladder Reserve Estimates. To give a clearer picture, insurance companies have case reserves to pay losses for each insurance claim. These reserves have to be watched really carefully so the company is compliant with federal regulations and can adjust to different market changes, all while covering paid losses without the company becoming insolvent. The core concept of TMAC's report is the fundamental loss development triangle. It is an industry standard to project the losses that are going to occur in the next accident year. This method, along with actuarial judgment, will allow insight about the business. There are several types of loss aggregation methods as listed, but for purposes of this discussion, we use accident year. In the actuarial profession, we use loss development triangles to track losses over time. The accumulated total claims amounts during an accident year is compared to the previous development year, and in this way, we can forecast ultimate losses and outstanding claims reserves. These payouts can change due to unsettled claims, where total losses are unknown, labeled IBNR, or case reserves may need to be adjusted due to unanticipated changes, labeled IBNER. The chain ladder method, or CLM, is a very popular technique to construct runoff triangles of loss development. We compare accumulated total claims amounts over a given period of time, in this case one accident year, then interact those sums with the age-to-age factor used to capture patterns of losses over time. The age-to-age factors, also known as loss development factors or link ratios, are ratios of loss amounts from one valuation date to another. The loss ratio captures loss patterns over time and can project where the ultimate losses may settle. There are several different methods to compute the average age-to-age factors. Here, we show the application of the volume-weighted average method, where we add up two columns and take the ratio. With each incremental increase to the age-to-age factors are then multiplied together with the total claims amounts resulting in loss from the subsequent time frame. In this paper, TMAC analyzes the chain ladder method in three components. The first is uncovering some implicit assumptions about the algorithm. Secondly, he'll derive a formula to measure the change in reserve estimates by using the standard error to create an interval for outstanding claims reserve and approximate the ultimate claims amount, which is the ultimate goal. Lastly, we discuss when the chain ladder method is not appropriate to use. When using CLM, we must understand three implicit assumptions being made involving the mean, independence, and variance. We discuss these in the following slides. The first implicit assumption in CLM is that the age-to-age parameters are the same for all accident years, so that the expected value of a future claim amount is equal to the most recent value multiplied by the constant age factor for all accident years. The chain ladder method also assumes the expected claim amounts only depend on the previous year's amounts. So we only use the most recent observed values to estimate future values. This implies that the following development factors are not correlated. The lack of connection between successive claims amounts leads to the second implicit assumption, that each accident year is independent of each other. Thus, the total claims amounts for a given accident year is also independent. A consequence of this independence assumption states the age-to-age factor is an unbiased estimator which works in favor of the actuary to predict ultimate loss with greater accuracy. Lastly, the third implicit assumption is not exactly explicitly assumed in chain ladder, but with this assumption, the volume-weighted average becomes the best unbiased estimator. That means that the volume-weighted average estimator has the smallest variance among all unbiased estimators. We may use other estimators such as the square-rated average or the unweighted average, usually arithmetic, of the development factors as well. The second topic of the paper is about the variability of chain ladder. With the previous three assumptions, the author computed the standard error of the reserve for each accident year. This is an estimator of the standard deviation of the reserves. The author also computed the standard error of the total reserve. Note that based on the previous assumptions, the reserves are correlated, so the standard error of the total reserve is not simply the sum of the accident years. One direct consequence of using the standard error, one can compute the interval of estimates of the reserves and the ultimate claims amounts. If the distribution is symmetric, we can use standard normal approximation. If the distribution is skewed, it is better to use log normal distribution. The third topic of the paper discusses when it is not appropriate to apply CLM because of the three assumptions. First, the age-to-age factors are the same for all accident years, and we only use the most recent value. Therefore, due to this assumption, we should not apply chain ladder if the subsequent development factors are correlated. The second assumption was that the claim amounts are independent for different accident years. We should not apply chain ladder if the claim amounts are dependent on certain calendar year effects. For example, if there was a major change in handling claims or greater changes in inflation rates, then claim amounts are dependent on those effects. If assumption 3 is not satisfied, then the volume-weighted average is actually not the best unbiased estimator. We may choose to use another estimator for age-to-age factors. To verify assumption 3, we can use two plots. First, plot the consecutive claim amounts between K+1 development year and K development year, and see if the scatter plot is approximately linear. Next, look at the residual plot. Plot the weighted residuals against the claim amount and see if there is no general pattern. If these two conditions are satisfied, then we can assume that the distribution satisfies assumption 3 for the chain ladder method. This concludes our presentation. Thank you for your time.